This is an equilibrium demonstration for higher chemistry. So first of all, the chemicals we're going to be using: some iodine crystals, some cyclohexane, and some potassium iodide in solution. And then we'll be using 3 test tubes, a couple of bungs, and a couple of measuring cylinders. So first thing I'm going to do is put 10 milliliters of potassium iodide in this test tube and 10 milliliters of cyclohexane in this test tube. But I'll do that off camera. So I've done that. So that's the potassium iodide solution on the left and the cyclohexane on the right. What I'm going to do now is add a few iodine crystals to each of them, but I'll do that off camera as well. Now that the iodine has been added, I will agitate these. I'll do this on camera so that you don't think I'm cheating. Hopefully you're seeing a colour change there. Potassium iodide has gone yellow, solution, and the cyclohexane with iodine in it has gone pink. An important part of this experiment is the striking colour difference between iodine dissolved in the polar potassium iodide solution or the non-polar cyclohexane solution. And because the potassium iodide is polar and the cyclohexane is non-polar, we can add the two together and they will be immiscible. So what I'm going to do here is very carefully add some cyclohexane with nothing in it to potassium iodide solution. I have to be very careful here. It should rest on top because it is less dense. Notice there we've got a nice colourless layer on top of the potassium iodide solution. We're going to do the same thing on the other side, except we're going to add this test tube to that test tube, which I will soon put in potassium iodide solution. This is a similar process to the other test tube, but because this is the cyclohexane, which will rest on top, I have to pour this one into the potassium iodide solution, and again being very careful. And here you see the purple layer sitting on top of the colourless potassium iodide solution. Now these two test tubes both contain exactly the same chemicals in exactly the same concentrations and ratios, but they look completely different. So how can that be? It's because they are not in equilibrium. If you leave these test tubes for a very long time, they will slowly reach equilibrium and will begin to look the same. But we can speed that process up by agitation. So I'll take both these test tubes, again I'll do this on camera, and shake them both, and hopefully they'll begin to look similar. Let them sit there and they'll separate out, and as you can see the bottom is yellow on both of them and the top is purple on both of them. It means they've reached their equilibrium state and they will not return to the previous state where one half is colourless and the other half is coloured. They will remain like this until something else happens to them.